right, Jamie, you ready?
For what?
I'm going to paint you a word picture.
Okay, let me get in my space. Go.
Okay. It's Sunday morning. The grass is high. It's time to mow the lawn. So you pull the lawnmower out of the garage, you start it up, and you start pushing it around your lawn. That smell of cut grass coming up through your nose. It's great. So you're almost done. You're close to the driveway where there's some rocks on the lawn, and your lawnmower goes over one of those rocks, kicks it across the street, kills somebody.
Kill somebody?
But it doesn't actually have to kill somebody. The idea is that a rock kicked by a lawnmower can have an equivalent amount of force as a bullet delivered from a .357 pistol.
Lethal lawnmowers. I like it. What else we got?
Well, continuing in the theme of accidental ammo, we have a construction site myth called glass guillotine. Goes a little like this. Pane a glass in a building. Guy walking down the street. Pane of glass comes loose. Shing.
Well, that sounds like a pain in the glass.
Exactly.
If we're going to be testing whether a rock effectively becomes a bullet when it gets hit by a lawnmower blade, we need to be someplace like this.
We've actually been filming in this very location for 10 years. Down there is the range in which Jamie and I first got trained to fire sniper rifles. And this is where we made hands out of chicken parts, high five, and cut them to ribbons with the off-gassing from a Magnum revolver. Today, we are using one of their more remote ranges. All right, here we go.
Oh! Remote, because in an episode devoted to accidental ammo,
What are we doing with all this plywood? You'll find out.
the MythBusters are bringing some ballistic bedlam to their soon-to-be-made backyard.
What did one sheet of plywood say to the other? We're screwed.
Yes, we could do this test on a real lawn, but remember, this isn't about whether lawnmowers cut grass. We know this. This is about what happens to rocks when they interact with a lawnmower. I walked in my own path. So we've created our lawn laboratory here in order to remove variables and to clearly see what happens to those rocks.
Our experimental design today is pretty straightforward. We are going to lay down these rocks. Now it's starting to sink into me what we're about to do. Turn on this gas-powered motor and run it over them. What we want to witness is what happens in the reaction between the stones and the blade of the lawnmower. This is going to be a horror show.
Our blue figures are painted onto styrofoam, and so if any rocks come out of the mower with any force, this foam is soft enough that it should easily show it.
The mowers when Jamie was a kid didn't even have wheels. They had a really interesting name. They were called, what was it? Oh, goats.
Okay, let's see if this thing starts up.
Modern metal mowers have debris deflection more than covered with this spring-loaded safety flap.
Nothing came out. We gotta pull that door.
But Adam and Jamie want to know what happens in the worst-case scenario.
It seems like the safety features work beautifully, but as you know on MythBusters, that's never stopped us. The first order of business, remove this little door with the word danger on it. There we go. Safety feature removed.
With the mower now poorly maintained, the opening on the right-hand side means any debris propelled by the blades will hit the styrofoam targets. Adam, standing behind the mower, should be safe.
What's going to happen?
3,
Well, one thing's for certain.
2,
Unless you're wearing hockey armor,
1.
you don't want to stand in front of the opening to that mower.
I don't want to do this anymore. This is terrifying. I start the mower, and I get into a rhythm. It's the most terrifying rhythm I've ever been in. I actually ended up by turning my entire body away from this rain, this shower, this firestorm of little tiny pebbles. One even flew up in the air and landed on my hat. And I can't even picture the physics required for that to occur. Good Lord! I ran out of steam, and that is fine with me. Here, I'm no expert with cameras, but that's bad. Am I right? That's bad? I don't ever want to be behind a mower doing that again.
While Adam was behind the mower, out of the line of fire.
I'm really sorry about that. I apologize here. I'll put that right there.
A veritable firestorm of stones and ricochets meant no one was safe.
Come here. Oh, my gosh. Hit, hit, hit.
With the foam onlookers peppered,
That went all the way through.
Wow.
the myth that a lawnmower can fling rocks at bullet-like force is clearly on the right track.
It threw this. That's heavy. With enough force to embed itself in this. I mean, I know that it's foam, but this is... I'm amazed.
So there's evidence the ballistic fallout is significant. But the Heinemann can't resist ramping it up.
This thing here is what you call a premium domestic lawnmower. It's a ride-on, and it's made to mow lawns fast. It's fun.
That's beautiful!
With an engine 4 times more powerful,
Jamie, are you ready?
I'm ready.
how much more havoc will Jamie wreak?
3, 2, 1, go! Oh, no.
I brought in the riding lawnmower and picked up where Adam left off.
Oh, my God. Stop! Stop!
As you can see, there are no rocks left where I mowed. That mower moved them successfully off to the side with vigor.
Turn it up.
How'd I do? You know, I don't really care. You might want to think twice before inviting a MythBuster to mow your lawn. I'm just saying.
Look, we have had fun so far, but it is important to remember that this entire story is about the interaction between a spinning lawnmower blade and a rock. How fast does it leave, and with how much energy? Now, were those rocks leaving the lawnmower at the speed of a bullet, or with the same amount of energy? That we don't yet know. I think what we got to do is take some of this equipment back into the shop, remove even more variables, and hone in to find out if they really are kicking those rocks with the energy of a 357.
The mower mayhem is set to continue.
Everybody okay?
But coming up next,
3,
the accidental ammo Armageddon
2, 1.
hits dangerous new heights.
I did not expect that level of carnage from our lawnmower.
Yeah, we might be onto something with that.
True, but a lot is going to rest on exactly how fast those rocks are actually going. But before we get to that, let's say we crank up the gore on another story.
You're talking about glass guillotine.
Yes, the myth is that if a pane of glass falls out of an office building and you're unlucky enough for it to find you on the street, it will cleave you right in twain.
Well, I don't know about that, but whatever happens, it ain't gonna be pretty.
No.
For us to do our glass guillotine experiment, we need something to cut, something that ideally would be like a human. And, well, I asked for some volunteers from the shop crew, but nobody stepped up. So I'm going to have to make my own, and to do that, I'm going to melt down a clear, flesh-like material and pour it into this human-sized torso mold.
Yep, for anatomical accuracy, Jamie's using a creepy mix of realistic materials.
See the way that tears? This is a polyethylene material, and it actually rips, just like flesh will rip. So I'm going to use this as a filler material so that when our plastic dummy gets impacted, it actually cleaves, if it's going to, like flesh.
Getting a human-like texture for their torso is critical.
There we go.
Adding bags of blood, not so much.
These bags are made for what's known as sous vide. It's a method of cooking, and it means that the plastic's able to withstand a fair amount of heat. And this will provide a container for the blood, which when we float this or hang it inside our mold, hopefully, if it gets hit with our glass guillotine, it'll bleed.
With the gratuitously gory innards placed, the pouring of the now superheated gel commences.
Lower down. It's funny to go back through our whole entire history of human analog production. Oh, there we go. I mean, we started off so primitively, just filling molds like this with dessert gelatin. All the way up to, last year we made A human analog that would actually get hypothermia while you watch.
It's all looking good. It's nice and clear.
In this case, for our glass guillotine, this one bleeds. And in 12 hours when it cools, we're gonna try it out.
It's a beautiful start,
Oh, it's beautiful.
but their bubble is soon burst.
That right there, that's a breach of one of our blood bags inside our human analog here. Doesn't look like they've all breached, but if one has, well, there's only one of two reasons. Either because the bag was improperly constructed or because they're all gonna breach. What this means to the final product, I have no idea. We just gotta wait till this cools and see what we get. This is how Jamie was born. Ta-da! Hey! Oh, he looks a lot better than I was afraid he'd look.
Yeah.
Wow.
I'd say it looks pretty usable.
Nice!
This is the first of our castings, and frankly, we were worried that we had ruined it. But while it's not perfect, hey,
Sorry.
it's usable, and it'll serve for one of our tests.
Clearly, if we're going to be experimenting with glass falling from great heights, we're going to need glass and we're going to need great heights.
Too low.
Now, glass is easy. Great heights, not so much. A little bit better. Not a lot of people want to let you drop stuff off of their buildings unless you come to a building like this.
Almost.
This is the Santa Rosa Fire Department's fire training tower. That's more like it. Today,
I hate heights.
we're going to be dropping large panes of glass onto unwilling ballistics gelatin test subjects. Absolutely perfect.
So we've got a 4-foot by 6-foot piece of 3/8-inch thick glass, like what they would have on top of a high-rise.
Not many people know this, but mimes actually practice behind an actual pane of glass.
And I'm going to hoist it to 75 feet,
Good.
where Adam and I are going to drop it.
Looking good? Now, when you're visualizing a pane of glass falling and slicing through someone like a guillotine or a sword, you're probably thinking of something that looks a little like this. But you also probably were watching us move around our pane of glass and thinking, wait a minute, that glass doesn't look sharp. It looks like it's got a kind of a square edge, kind of like that. That's because the glass in an office building is called tempered glass. It's made to be very hard, and it also doesn't break into shards. It actually breaks into many, many thousands of little tiny chunks, kind of like this. It didn't break. Allow me to say this again. It breaks into many little pieces like this. There you go. So it's more akin to actually hitting the melon with the back of my blade rather than the front, like this. Now, is that what's going to happen to our guy when our glass falls on him? Frankly, I have no idea. I'm just as curious as you are.
All right. Nobody underneath this. Jamie, I will meet you up at the top.
Here we go.
I hate heights. I know nothing's going to happen to me when I'm in these things. Man, this is scary, but I've always been that way. I just hate heights so intensely. It's just awful.
Yeah, that's it. Jamie, this is working beautifully. You know, I can't help but feel like we're about to enact a scene in a movie called Clumsy Window Movers.
For clarity, it is worth restating that what we are looking for from the glass here is not whether or not it kills him.
Okay, now, I figure we hoist it over our heads.
Yeah. Although that would be the end result no matter what, if it hit him.
Okay.
3. Oh my God. It's that it would cleave him in two like my sword did with the melon. Shing.
3, 2, 1.
Oh!
It did a little turn right at the very end.
It looked like it was going to be perfect, and at the very end, it fishtailed.
Oh my gosh. It was so close. For like the first couple of seconds, it seemed to be falling perfectly like a knife towards him. I'm like, oh my God, it's gonna hit him. It's gonna hit him. And then what feels like just before it got to our dude, it went like this and hit the ground perfectly flat and spread in every direction.
Oh my goodness. It looks worse down here than it did up there.
Oh my God, it's so pretty.
When I was like 10, I would have taken these home and pretended they were diamonds and pretended I had treasure.
I would have sold them to the neighborhood kids and made a profit.
It's clear that this test was a fling and a miss. To stand a chance of a direct hit split, they're going to need a plan B.
What do you think? Should we head back to the shop and make a system for guiding the glass?
Yeah, I've got some ideas.
Me too.
Lurking innocently in your garden shed, a lethal accident is waiting to happen. Or is it?
We have been trying to determine whether a lawnmower can fling rocks with the same amount of energy as a bullet. What we'd like to do is measure the speed at which the rocks are leaving the lawnmower and then see how that compares to the speed of an actual bullet.
Before comparing actual bullets, they're measuring the mower.
Why am I taking the motor off? Well, for us to test it in the shop, we need to look closely at it and run it for a while. And so instead of having this noisy, smelly gasoline engine going in here, we're just going to swap it out with an electric motor, nice and clean and quiet. This thing's stuck. And we got it. Ah! The way this motor is wound, it's going to give us 100 RPM for every volt that it sees. And so given that the gas engine ran at 3,600 RPM, we need to feed this 36 volts to see the same RPM. But the thing is, if we give it that voltage all at once, it's going to spin that blade up to full RPM in like a millisecond.
You just built a lawnmower that I want to be behind a blast shield in order to start.
And that's scary. It might end up putting the blade in the wall or in me or something because something's going to break. So I've got to figure out a way of doing it a little more gently.
To gently deliver that power, once again, Jamie uses equipment in ways for which it was never intended.
This is working perfectly.
He's hooked up a DC-powered welding machine to a lawnmower.
I love it when things actually work the way you hope. I mean, it is somehow a little counterintuitive to run a motor off of a welder, but
Yeah.
DC power is DC power.
That's amazing. All right, let's get it up on a stand.
We need to be able to deliver the rock to the spinning blade in a way that we can actually see what's going on.
Now it's looking like something.
But Adam and I have come up with a way of doing it, which involves putting the whole mower up on top of a sheet of clear acrylic, and then we can see from underneath.
Yet another in a long line of pristine surfaces soon to be destroyed and sullied in our hunt for the truth.
And we'll simply raise the mower, get the mower up to speed, and then lower it down onto the rock. Bang. So how are we going to keep this stuff from going all over the shop?
Well, we've cut away the whole side here, so we wanted to go there. So I thought we'd put some uprights and plywood here to protect the walls. We already know that a lawnmower can hurl a rock at a fairly good speed. But we don't know what that speed is. Cool. All right. That's position one, medium-sized rock. So we're going to power up this lawnmower to its full speed. We're going to feed rocks into it, watch them on our high-speed camera, and measure exactly how fast they leave. You ready?
I'm ready.
Well, let's do this.
18, 25, 32, 34, speed.
All right, here we go. Dropping a lawnmower onto a rock. 3, 2, 1. Cut it.
Blink and it's gone. Because when the mower is lowered, the blade instantly slices the stone into chunks.
Oh, wow, just absolutely decimated that piece.
Question is, were any of the fragments moving at a bullet-like velocity?
The fastest chunk was going 250 feet per second, and that's actually pretty significant for a chunk of rock about 1 inch long and a ½ inch wide. But we're going to keep running this, see if we can't find even faster debris.
250 feet per second is a good start.
Okay, so we got a whole pile going in.
But this time, they're giving their mower more to aim for.
Start her up.
What could possibly go wrong?
Speed.
Dropping big pile of rocks. Cover your eyes. 3, 2, 1. Cut it. Everybody okay? Chunk. Chunk made it out.
Well, I hope we got the shot because that was the sound of the blade coming off of the motor.
Oh, really?
Yeah.
While Jamie inspects the carnage,
Wow. We cracked our acrylic bottom.
Adam, ignoring the mess he's made,
There's the blade.
cues up the high speed.
Wow, dude. We got the hit that I was hoping to get. Watch the leading edge of the blade here.
Boom.
That piece, 400 feet per second, 272 miles per hour.
Well, I feel like we're in some very dangerous territory.
Dangerous for sure. But the crucial question is, how does it compare to the speed of a bullet? Well, Jamie, with high-speed camera in tow, fired up at the gun range to find out.
3, 2, 1. The slowest bullet we measured went at 1,000 feet per second. The 357, which was much faster, went at 1,400 feet per second. Now, the fastest rock we got off of our lawnmower went 400 feet per second, which is nowhere close.
But it's not busted right there. No, because while this rock is bigger and slower than this bullet, it's heavier. What I'm wondering now is there a rig I can build that can compare the amount of energy the bullet brings to the equation and compare it to the amount of energy the rock brings? I think I can.
3, 2, 1.
While Adam cogitates on how to illustrate energy comparison, he's thinking outside the box for glass guillotine.
Clearly, dropping glass off the building isn't going to be a repeatable way for us to test this story. Oh! So we're going to need to come up with a mechanism for reliably making the glass hit exactly where we want. And I have an idea, except in order to talk about it, I want to build a little model of the fire training tower. And instead of an exotic material,
I love making corners match up.
I'm just going to use this cardboard box we just got in the mail. Ta-da! I know it doesn't look like much, but check this out. This coat hanger will be a welded steel rack which we sit on the lip of the building. We're clear. These red pieces of parachute cord are guide wires which we mount to the ground. Awesome. The glass has riders on it that keep it aligned with the guide wires.
They say the glass is tempered, but is it bad tempered?
We bring it up with a winch.
Go ahead and winch up the glass.
Here she comes.
Drop it from the top and tink! It hits our test subject square where we want him to and slices him right in half. Or not. That's what we're going to find out.
And with Adam's model design rigged, the glass is poised to come crashing down in controlled fashion.
It is really just about to happen. I can't wait to see this.
It's time to find out if our unsuspecting bystander will be neatly split in two.
In 3, 2, 1.
Here it comes. Ah! That was perfect. Dude, that was beautiful.
He's still in one piece.
It looks like he's still in one piece.
Of course, there's blood everywhere.
Well, every one of our methodologies worked beautifully. The glass dropped, it hit our dude exactly where we wanted it to, and it did not cleave him in twain. No, it merely beat the living crap out of him. But there's still only one dude. There's not two half dudes. Gotta try something else.
Yep, this slasher story
It's gonna be a horror show.
is about to get real edgy. Could a 1 in a million high-rise slip ever really slice you in half? Not according to the evidence so far.
And you might be watching thinking, of course it didn't, you idiots. That tempered glass you dropped had this big square edge on it. But that's the thing with tempered glass. It doesn't break and have sharp edges. For that, you've got to move to plate glass. Now, they don't use plate glass in office buildings specifically for this reason, but for due diligence, we've got a piece of plate glass here, and we're going to break this so that we get a nice, clean, broken edge of plate glass.
All right.
And we're going to drop that on the next unsuspecting bystander we pulled out of our mold.
Okay, I'm gonna move him in.
Yep.
Our next victim doesn't have blood bags.
That is right down the center.
Not quite as much fun, but a little bit more consistent as far as the physics.
Go ahead and raise him in 3, 2, 1, go.
While it's on its way up, I feel confident that I think that is going to slice our dude in half. The edges of that glass, they're really sharp. It's going to be a horror show. All right, go ahead and count it down and let it go.
In 3, 2, 1.
Here it comes.
Oh, it's good, it's good. That was beautiful. I mean, I don't know how well it worked, but it looked great. Dude, that would be cleaved, as I've been saying all episode long, in twain.
Not exactly a bullseye to the brain, but in twain, he truly is.
I couldn't see that chunk fly off of him from where I was standing. It just looked like unfettered destruction. But dude, that's amazing.
These two dummies tell the whole story. The first one, we dropped a piece of tempered glass onto, and they manufacture that glass so that people don't get cut. And the result is appropriate to that. Our guy would have had his skull crushed and a lot of bones broken, but he wouldn't have been cleaved in half. The other one, we dropped a piece of plate glass on that had a broken edge that was very sharp, and as a result, he got cut cleanly in half. The end result is the same. He would have died. Take your pick. Can glass falling from a high-rise cut you in two?
But this is an interesting one because it's kind of a yes and no situation. If it's the glass they make high-rises from, then no, it's not going to cut you in two. It's going to kill you, but it's not going to leave you in two parts. But if it's the wrong kind of glass, then absolutely it can leave you in two big chunks.
So right kind is busted, but wrong kind is plausible.
Let's say plausible.
All right, I'll buy that.
All right, let's get out of here.
Back on the trail of the Stone Cold Killer. Adam and Jamie have proven a rock from a mower does not travel as fast as a bullet. But speed is not the only vicious vector.
So we were looking to compare the amount of energy generated from an impact with a bullet with the energy generated from the impact with a rock. So imagine that this hammer can swing like a pendulum. Then let's take a gun and shoot the face of this hammer. What's going to happen? It's an indicator of how much energy the bullet brings to the equation. Now, if I fire a stone at the same hammer at the speed it would be kicked by a lawnmower, and the hammer moves the same amount, well, then we could conclude that the amount of energy being brought to the equation by the bullet is the same as the stone. That's the theory anyway. Let's see if it works.
Yep, the heavy stone may have been moving more slowly than the lighter bullet.
That's beautiful.
But this pendulum rig will illustrate and compare the energy of each. Its acrylic impact pad will efficiently transfer the energy of the bullet to the pendulum and can be replaced for each test.
Well, that looks nifty.
With the rig ready to swing, the first test will be to measure the bullet's impact.
Okay.
And for that, it's back down to the gun range.
Gun is hot. All right, 357 on your mark.
Okay, here we go. Hopefully this doesn't wreck the rig. In 3, 2, 1.
The pendulum peaked at 60 degrees, but working on the basis that
If it ain't repeatable, it ain't science.
the guys go again.
In 3, 2, 1.
Nice.
That looked pretty consistent.
We did our two tests with 357, and they were consistent. They were about 60 degrees. So we've got the data we need to move on to stones out of a lawnmower.
But if you thought that means no more guns, then think again.
Wow. Because stones from a lawnmower are hard to aim. Because Adam's pendulum target is very small. We're going to take the lawnmower out of the equation and use a pneumatic launcher instead. I'm going to first check to see that it's shooting the rock at the correct speed. 406.
Seriously? Awesome, let's bring it in and shoot this thing.
And then we're going to bring in Adam's energy rig, hit it with a rock shot at 400 feet per second, and see how far up the pendulum goes.
This is it.
Good to go? Okay, safety's off.
Will a stone the same mass and velocity
Firing in 3,
as the fastest speed test stone
2,
match the energy of the lighter, lethal bullet?
1.
Dude, we gotta see the video, but I swear that went past 60 degrees.
With the crucial shot queued up,
All right.
did the rock hit the right angle?
See how high it actually went. Wait. Oh my gosh, dude! Dude!
It went above the 357.
That's 66 degrees. That's more energy from the rock. I'm sorry, I'm yelling, but I totally didn't expect this result. That is more energy from the rock than from a bullet from a 357. That is amazing. Shocking. Totally awesome. I have been expressing my doubts about confirming this story since the beginning. I just never thought the rock was going to have anywhere close to the amount of energy of a 357 bullet, and yet it exceeded it. I knew lawnmowers were scary. I just didn't know how scary. So with everything that we tested, I think we have definitively proven, and frankly I'm astonished by this, but that a rock thrown from a lawnmower can possibly have as much or more power than a bullet from a 357. I'm astonished, but this one's confirmed.
Yeah, I was surprised too. But you know, that gave me an idea.
What?
I want to make the lawnmower from hell.
If you do that, I'm gonna go home and hide.
With typical enthusiasm for engineering extremes, the Heinemann's going all out to turn a dream domestic mower into a deadly weaponized nightmare. And the key to his hellish vision
That's going to be sweet.
is to load up with a whole load more power.
Oh my God, that's one big battery. What this is a bank of about 90 volts at about 1800 amps. That means that shorting some of these would pretty much be like setting off a stick of dynamite.
What are we doing back here at the Chabot gun range? Well, remember that we have absolutely determined that a lawnmower can hurl a rock with the same amount or greater force than a bullet from a 357. That means that a lawnmower can be weaponized, and that fact, well, let's just say that fact was too tempting for Jamie.
When it comes to terrifying engineering and gratuitous ramping up, the Heinemann has history.
I call it my little pop gun.
When he decides to go over the top,
We want more?
it's a good idea to duck, cover, and wear a hard hat at a safe distance.
Introducing the lawnmower from hell. You've got 200 horsepower of electric car motors, 1,800 amps of lithium batteries. They'll be spinning a 50-pound tool steel blade at upwards of 5,000 RPM. Put it all together, and you really don't want to try this at home. First up, we're going to give the beast here a little taste. Just a little taste. It's a bucket of blue water.
Go for it! Oh, I've barely been so happy to be behind the bulletproof shields. He's approaching. 6 feet. 4 feet. 2 feet. It goes! Dude, that was beautiful. Tell you what, why don't you take this thing around the corner? I'll set up a really fun course for you to implement as much destruction as possible. I'll let you know when we're ready for you.
Okay.
So how you put a ridiculously souped up and almost definitely dangerous lawnmower through its paces? I decided on a broad range of material. Now we're getting serious. I wanted some small hard things to get that bullet-like carnage, like a frat house lawn. And I wanted some big things to get some awesome high-speed camera carnage. I call this section the palate cleanser. My prediction? Gotta have some willing victims. Frankly, I just hope no one gets hurt. Last one, like some sort of kumbaya dance circle. In fact, it's a circle de los muertos. Here it comes. I'll bet Jamie's just a little bit nervous right now. Oh yeah, watermelons are first on the menu. Holy crap, something went flying. I think we had a total failure of the rig there. What just happened?
What happened was scary as hell.
The axle broke.
Oh yeah. Oh dude, the axle sheared?
Look at this.
Oh, it went, oh my gosh.
Well, there's your problem.
Yeah.
Oh, shoot. Well, that's the end of today's fun.
Well, you know, I intended to go over the top with my lawnmower from hell. And I guess I did. Maybe a little too much, though. Like we always say, failure is always an option.
And you know, this is the perfect example that you can learn as much from a failed test as a successful one. What we learned in this test is, well, that Jamie has built something far too dangerous to turn on again. He is literally sitting on a drivable, cutting, whirling, slicing blender of death. Well, we could put another blade on it, to be sure, but we're going to bow out for right now. At least until Jamie can figure out how to make this thing safe. Then we will be back.